Hello everyone, welcome back. This is part 3 of our video series to build our regression model. So far what we have done is we have loaded our data using Excel Reader node. Then we have explored our data using Data Explorer node. Then we did some string manipulations, as you can see here. This is the function we used, right? Then we converted our column, which was originally string, to a number. Then we also took care of the missing values. So far we have gotten this far. Now the one thing that you need to remember is that uh, if you look at pardon me, if you look at the data here, uh, you will see that this column origin has values as 1, 2 and 3, and this is nothing but a code. So therefore we will have to find out what this actually means. What does 1 mean? What does 2 mean? What does 3 mean? And so in order to figure that out, we have a file in our computer, and it is called the origin table file, right? And since it's a CSV comma separated file, I'm going to use the CSV Reader node here, okay, which again you can get from your node repository. Now the way to use this is pretty simple and straightforward, which we have gone through in the past, but I'm going to quickly refresh your memory here. Right click, go to configure, and select your file and click OK, and then execute this. And once you execute this, then the data will be loaded in KNIME. Now this is a node that we will have to use because we have data in two different places. One is here, which consists of the origin code and the country associated with the code. And then we have all the other data over here. So we are going to use this joiner node so that we can join these two data sets. So this is how we're going to do it. We are going to configure this. The way to configure this is very straightforward. You have two tables, left table and the right table. The left table, which has most of your data, you choose the column that has the value 1, 2 and 3, which is basically the code. So in this case it's origin. The name of the column doesn't have to be exactly the same. That's not the point. The point is that it has to match in terms of its purpose and meaning. So here the origin column has all the code, and origin code in this right table, the small table, and the column is origin code. So we are going to use this and we are going to execute this. Once we execute this, then you're going to get this table. It has now the origin name and origin code from the right table and all the other columns from the left table. So in this you will see origin from the left table, right? So you will see that for this particular row we have origin as 1, origin code as 1, and origin name as America. So this is how you get your data from two different data sets into one. Now if you explore data using our friendly Data Explorer node, just right click and configure this. Nothing to change here really, and execute this. Once you execute this, you're going to get this interactive view. Here you can see the minimum, maximum, mean and all of the things. Most importantly, look at number of zeros or missing values or nans. Then also look at the numerical information. Here you can see that the origin name column has 3 unique values, and those values are America, Asia and Europe. All right, so these are the 3 unique values. So far so good. Now there is one other important thing that we have to do before we build the model, is to convert these values America, Europe and Asia by doing what we call as one hot encoding. And the purpose of it is to change these categorical variables into um, zeros and ones, so that the model will understand if it's made in America, it will consist of the value 1, and if it's in Europe, it will consist of value 1. Basically, it will create 3 columns: America, Europe, and Asia. And if it is made in America, it will be 1 for that particular column, and so on and so forth. Now, proof is in the pudding. It's easier to see it and understand it, so I'm going to show you. My bad. Let's look at the configuration here. We are going to use one-to-many or one-hot encoding for this particular column, origin name, and we're going to execute this. And once we execute this, please look at the process data, and you will see that it has created 3 columns: America, Europe, and Asia, as I mentioned before. And if the car is manufactured in America, it will consist of value 1 in this column. Similarly, if the car is manufactured in Asia, it will consist of value 1 in Asia column, and it will be 0 in Europe and 0 in America. Same thing here. If you go to Europe, it's made in Europe, so you will see that it's a value of 1 in this column and 0 in America as well as Asia. So that's how it does it. This is one hot encoding, very useful technique to build your models. Now, we have several columns that are redundant, and so before we build the model, let's take care of the redundant columns and or any other column that we think is not going to be beneficial. So we're going to use this node called as column filter, and then double click or right click and go to configure, and out of all the columns that are available, I just want these columns that are in this included section. The ones that are excluded, I don't need those. So we need miles per gallon because we are doing supervised learning, and so we need information about our target variable. In this case, our target variables is the miles per gallon column. We're going to use cylinders because we're going to use this data for building our model. We're going to use displacement, weight, acceleration, the new horsepower column that we created, and America and Europe columns that we created. However, please note that we're going to get rid of this one column, Asia, because these 3 are correlated in the sense that if the value in America is 0 and also 0 in Europe, it's obviously 1 in Asia. It's a no-brainer. So we don't need to have all these 3 columns. We just can have 2 columns, and that'll be enough. And that's what we're going to do. And we're going to run this, and once we execute this, you're going to get a neat and clean data set that has the target variable and all the other independent variables. We call the target variable also as a dependent variable, and these are all your independent variables. Now we are ready to build our model, which we will do in the next video. Thank you so much.